So this is just an integral problem, and always remember to write these two things, because that's the easiest way to get marked off for points. So when you take the it can be integral or called antiderivative. So when you take the antiderivative of this, what you do is you add, so right here. So when you take the integral, you have x raised to some power. So what you do is you add 1. Well, usually you subtract 1, but for integrals you add 1 because it's the antiderivative. And then you multiply by 1 over n plus 1. And don't forget the c. So here, that's what I did. All I did was add 1. And 1 can be written as 2 over 2. That's still 1. And so you'll get x to the 5 over 2 power. And then here, there's always like a 1 there. X to the 1th power, and you just add 1, so it becomes 2. And then over here, if it's just a number, you just add an x to it. So over here, like I said, you have 1 over n plus 1, the new number. So since over here is 5 over 2, it's going to be 1 over 5 over 2 plus, and then since this is a number in front of it, you just keep it in front and then multiply it by 1 over the new number, which is 2, and then you just keep this the same. And since this is 1 over a fraction, you can flip it, so it becomes 2 over 5. Same thing. And then here, since you're multiplying, it can become 8 over 2. And then your final answer, your simplified answer, will be the same thing, 2/5 times x to the 5 over 2 plus, and then you can simplify this. 8 divided by 2 is 4, x squared plus 7x. And then the final thing is c. See, when you take the antiderivative, you'll get this answer. But you can also write any c you want, and c just stands for a number. Because if you think about it, if you take the derivative of this, right, you can have any number here. You can have plus 1, but when you take the derivative of a constant of 1, that 1 will disappear. And that's why we write that constant. So I hope that helped, and thanks for watching.